Hello. Here we're going to look at the ArduStomp testbed and demo modules. What we've got in front of us is here the circuitry for the ArduStomp, which is the pedal to control the ArduGuitar. So we have various aspects we're going to look at. This is the Bluetooth module, so this will act as the master Bluetooth module. Here we can see some of the controls. If we zoom in a bit, and we can see them a little bit better. These are buttons which will be eventually foot buttons, foot switches. So we have volume plus and minus, tone plus and minus. We have a neck, middle, and bridge button to switch on and off the pickups, or cycle between, for the bridge, off, both, or split. And we have the preset button which will cycle through all the presets. And we have the automatic button which will start the automatic function, which will go from preset to preset as previously selected in the automatic configuration file. And here is the last one, which is a save button, which will write the current values to the current preset into RAM. This is not saved to disk. Here, although you probably can't see it very well, is the SD card reader. This is the SD card reader. On the SD card are the configurations, so the presets and the automatic configurations. Over here, if we go back now, we can see the LEDs. These LEDs represent various things. The first one is the connection, so if it's connected to the Bluetooth module, then we have power. Then we have the tone settings. This is in binary with the most significant bit first. So in other words, this represents 4, 2, and 1. So if they were all lit, we'd have a level 7. The valid values are 0 to 5. The same for volume, 0 to 5. Here is the automatic. So when automatic is on, this will be white. Here we have the presets. So we have again binary counting from 1 to 4. There's 4 presets, and then we have the indicators for which of the pickups are active: bridge, middle, and neck, middle, and bridge. Bridge split here, or both, or off. And over here, this is the simulated guitar. This is simply an Arduino connected to a Bluetooth module acting as slave, which will receive the commands via Bluetooth which are sent from the StompBox and reply with the appropriate reply. So now we're going to do the actual demo. And to do that, we should go through the various processes. So we're going to start it up. First thing to do is connect to the computer. And to initialize, we're going to execute it. We're going to load the code again, just to be fresh. Now the code is loading. It's still loading. Okay, we finished loading. Now it's initializing, it's reading from disk. So now here we can see the Bluetooth module is looking for its partner. It's trying to connect. So I will turn on the guitar simulator. That's now on, and when this one goes to green, that means it's connected. So now we're connected, and you can see that the LEDs light up, meaning, as I said before, so we can look through them very quickly and understand what they mean. So we have the connection LED. Yes, we're connected. Yes, power is on. These are the tones, so we have 4 plus 1 is 5. Here we have the volume. That's 2 plus 1 is 3. Auto is off. We are on preset 1. We have the middle and both of the bridge coils on. Now, if I go through the possible controls, so if I increase the volume, you can see how the volume LED change. And I decrease the volume, it goes off. Okay. Same for the tone. We can decrease it, turn it off, turn it off. Let's turn the volume all the way off. Now that we can look at the next one, the neck, turning on and off. the middle pickup turning on and off, and the bridge pickup cycling from split, so it's off, both, split, off. Turn them all on. Turn all the pickups on. Now suppose we wanted to save that. As you can see, we are in configuration preset 1. Suppose we want to save that, so we push the save button. It confirms with some flashing, and now preset 1 is this configuration, which is useless configurations because volume and tone are both to 0. Now if we cycle through the presets, we can go in preset 2, you see how we've passed to 2, preset 3, preset 4, and back to preset 1, which is as we said. Another thing we can do is automatically cycle. So I previously created a configuration file which will cycle through all the presets one after the other infinitely with a 1.5 second delay at each one. So here we turn it on, the light goes on, we're now at preset 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1. All that is pretty cool. We're now going to look at what's actually happening on the screen while this is going on. Okay, so we're back now. We're looking at the traces which the ArduGuitar is sending via USB back to the computer. And this is just a serial connection, and we're monitoring the information being sent back by a serial to the PC. As you see, we have every 10 seconds we're measuring the amount of free RAM. This is a very approximate measure, and you can see we have 626 bytes of free RAM available, and that is constant. It's not degrading, so we have nothing leaking. Anyway, we're not doing dynamic memory allocations. So now let's send a command. For example, let's turn on the middle pickup. So we go to the middle pickup button and turn it on, and there we see we've sent the command 03255, and we got the reply X03255, which means it's okay. So we now have it okay, and that was okayed. And then we go back to our thing, to our pulse measurement. However, if we do a full preset cycle, we see a lot of commands go through. Those are each one representing different things. We sent the 9255, that happens to be one of the volume. There's a volume, 3 volume commands. There's a tone command. Then there's the neck, middle, and bridge, and then the bridge split command. Those were all sent appropriately. You can see there's not very much things sent. Now if we go to automatic mode, we see how all these commands are automatically sent, and we're getting the ACKs. This is synchronous communication. After we send a word, we get a word as an ACK. And that's what we're looking at, and that's how it works. It's relatively simple in circuitry. The code is a bit complicated, but it was tough getting it into the small amount of memory available, especially on the SRAM for variables and dynamic and static allocation. That's all we have, and there you can see our circuit is still working as we previously thought, and this will work for a long, long time, apparently forever, because it's never running out of memory. Thank you, and I'll show you the final version when it's actually into a StompBox as soon as I have it ready. See ya.